Hey, curious people. Welcome to Quite Intriguing, the channel where we dig into the most mind-blowing, eyebrow-raising, interesting ideas out there. Today, we're exploring 6 of the strangest phenomena in the universe, things that even the smartest astronomers are still scratching their heads over. So get comfortable, because we're diving into some truly cosmic oddities, from stars that are so round they're almost unsettling, to signals from space that no one's been able to explain for decades. And while you're at it, please remember to make use of that subscribe and like button. Let's get into it. Let's start with the most round thing in the universe. Sounds a bit meh, right? But it's actually incredible. Most objects in space, planets, stars, even our own Earth, end up a bit squashed because they're spinning. But one object in particular, a neutron star named PSR J348 plus 432, has achieved levels of roundness that put even the fanciest billiard balls to shame. Located about 2,600 light-years from Earth, this neutron star is only about 20 kilometers in diameter, which makes it about the size of a city. But the real kicker? It's 2 times the mass of our sun. Yeah, that's right, a tiny, ultra-dense ball that could fit in your city limits, but with the mass of 2 suns crammed inside. This density has a weird effect. It forces the star into an almost perfect sphere. In fact, PSR J0348 plus 0432's equatorial radius is only about 0.003% larger than its polar radius, which means that this star is essentially flawless. For perspective, that's less than a 1 part in 100,000 deviation from roundness. This thing is smoother than anything we can create on Earth. Other contenders, like the white dwarf WD 1856 plus 534, about 80 light-years away, are round but can't quite compete with PSR J0348 plus 0432. So there you have it, the roundest star we know of in the universe. And if that isn't impressive, I don't know what is. All right, from perfectly round to cosmically huge, let's talk about the Great Attractor. If that name sounds like a sci-fi thriller, it might as well be, because this thing is seriously mysterious. The Great Attractor is an area of space about 250 million light-years away where something very big and very powerful is lurking, and it's pulling everything around it, including our Milky Way galaxy, towards it at breakneck speeds. In the 1970s, astronomers started noticing that galaxies, including our own, weren't just randomly drifting around. Instead, they were all moving toward this one point in the cosmos. So what's the cause? The most popular theory is that the Great Attractor is a gigantic mass of dark matter, the strange invisible stuff that makes up about 85% of all the matter in the universe, but that we can't directly see. Dark matter doesn't emit light, so it's a bit like the universe's shadow, and this shadow has some serious gravitational pull. To put it simply, the Great Attractor is like the cosmic dance partner no one invited but everyone's stuck dancing with. And while we may never get close enough to see what it actually is, it's reshaping galaxies for millions of light-years around it. Next on our list is one of space's biggest what the heck was that moments. Fast radio bursts, or FRBs. These are super short, super intense bursts of radio waves that come from other galaxies. How short, you ask? Each one lasts just a few milliseconds. Imagine something the size of a city putting out more energy than our sun does in a year, all in a fraction of a second. Now you see why astronomers are so excited. The first FRB was discovered in 2007, and since then, we've picked up hundreds more. But the big question is, what causes them? Theories range from the wild, aliens, to the more grounded, cataclysmic events like star collisions or the collapse of massive stars. We still don't know for sure, and that mystery is part of the fun. These FRBs give us a unique way to study what's happening in galaxies far, far away, and they even let us learn about the stuff in between, like gas clouds and intergalactic plasma. So, whether it's aliens or exploding stars, FRBs are like cosmic postcards sent from places we've barely begun to explore. From fiery bursts of energy to the coldest place in the known universe, let's talk about the Boomerang Nebula. This is a preplanetary nebula about 5,000 light-years away in the constellation Centaurus, and it's an absolute deep space freezer. With a temperature of minus 272 degrees Celsius or minus 458 degrees Fahrenheit, the Boomerang Nebula is colder than the cosmic background radiation, which is usually considered the default, temperature of the universe. But how did it get so cold? Well, the Boomerang Nebula was formed when a dying star started shedding its outer layers of gas at incredibly high speeds. This gas expanded so quickly that it essentially cooled itself down. Think of it like opening a can of compressed air. As the air comes out, it gets really cold. In the case of the Boomerang Nebula, this effect created a chilling effect like nothing else we've seen in space. The nebula's shape, which actually resembles a bow tie more than a boomerang, adds another layer of mystery. It's basically the universe's weirdest air conditioner. Now let's talk about gravitational lensing, which is when massive objects in space act like giant magnifying glasses. When a massive object like a black hole or a galaxy cluster sits between us and something far behind it, the gravity from the object bends the light from whatever's behind it. The result? Some seriously trippy visuals. Imagine you're looking at a distant galaxy, but because there's a black hole in the way, that galaxy's image appears bent, stretched, or even duplicated. Sometimes the bending is so strong that it creates a perfect ring around the lensing object, known as an Einstein ring. This effect lets us study galaxies that would otherwise be too faint to see. It's like the universe's way of giving us a telescope upgrade. Plus, gravitational lensing gives scientists a perfect test for Einstein's theory of general relativity. This phenomenon confirms that massive objects really can warp space-time like a rubber sheet, bending light, and giving us all a better look at the universe's more elusive features. Last, but certainly not least, we have the WOW signal, probably the most famous space mystery of all time. Back in 1977, a radio telescope at Ohio State University detected an incredibly strong and narrowband radio signal coming from the direction of Sagittarius. Astronomer Jerry Eman, who was monitoring the data, was so shocked by the intensity of the signal that he scribbled "wow" in the margins, and thus the WOW signal was born. This signal lasted a full 72 seconds before it faded, and scientists have never detected it again. The frequency of the signal was right around the range that hydrogen, the most common element in the universe, naturally emits, which made it even weirder. The signal has remained a total mystery. Could it have been a cosmic accident, a broadcast from an advanced civilization, or just random space noise? Whatever it was, it's never shown up again, leaving us with one of the most tantalizing mysteries in the search for extraterrestrial life. And that wraps up our journey through the strangest, most intriguing cosmic phenomena out there. From unnervingly round stars to possible alien signals, the universe is packed with things that keep us coming back for more. If you loved this dive into the weirdness of space, give us a thumbs up, hit that subscribe button, and don't forget the bell icon so you'll never miss a new episode. This is quite intriguing, and we'll see you next time.